Okay, I'd like to start lesson 7, graphing reciprocal of linear functions, by looking at the function y equals x. Okay, so what we're going to do is we've got a table of values here, and of course this is our function y equals f of x, and the reciprocal we know from grade 7, 8, 9 when we started doing division of fractions, right? If we were to divide, for example, 2/3 by 1/2, then we would actually multiply by the reciprocal. So that would be 2/3 times 2/1, which would of course be 4/3, okay? The reciprocal is basically, right, our numerator and denominator switch places, okay? We flip the fraction, we can say, okay? If I look at the function y equals x, or y equals, f of x, being y equals x, and then I want to also look at y equals 1 over f of x, okay, where our function is x, and then 1 over x. I want to look at some competing points. We know how to graph y equals x, okay, and we can do that. That goes through the y-intercept at 0, okay, and our slope is 1. Okay, if we think of that as y equals 1x plus 0, right? Our y-intercept is 0 and our slope is 1 over 1. Now if I look at different points on that function, when x is -10, y is -10. Okay, x is my input. I'm inputting all of these numbers in here for x. When I get x is -10, I get y is -10, and -2, -2, -1, -1, and so on. Okay, all of these values are in fact the same. Okay, because y is equal to x. Now if we look at the reciprocal function, y equals 1 over x, if I look at the reciprocal of 10, the reciprocal of 10 is, or -10 rather, is -1 over 10. And the reciprocal of -2 is -1/2. The reciprocal of -1 is -1. The reciprocal of -1/2 is -2. Okay, the reciprocal of 0 is, of course, what's the reciprocal of 0? 1 over 0, which is undefined. Okay, and if you see that in your calculator, or if you put 1 divided by 0, you'll get error, which actually means it is undefined. The reciprocal of 1/2 is, of course, 2. The reciprocal of 1 is 1. The reciprocal of 2 is 1/2, and the reciprocal of 10 is 1/10. So let's look at some of these values. If I look at, for example, let's just pick the value here, these 2 points, okay? We'll plot a couple of these. On my original function, when x was -1/2, y was -1/2, which was down here, okay? Right here. Here's the point, -1/2, -1/2. The value on my reciprocal function, okay, I'm still putting the same, so instead of -1/2, -1/2, on my reciprocal function, I've got the value -1/2 and -2. Okay, that's what it becomes. So -1/2, -2. It's right there. Okay, I'm not going to necessarily keep all the coordinates there because we're just going to get too busy, but that new point is -1/2, -2. If we look at a point like -1, -1, let's just glance at this one. Okay, my original point was -1, -1. That's the point on y equals x. Okay, if x was -1, y was -1. Y equals 1 over x. If x is -1, y is still -1, because 1 divided by -1 is still -1. We call these 2 points, we call these points invariant points, because when x is -1, y is -1, right here is an invariant point. And let's do that actually in blue. We'll do our reciprocal function here in blue. Okay. If I take the value -10, when x was -10, y was negative 10, way down here. That's the point, way down here. When x was negative 10, y was negative 10. But on our reciprocal function, when x is negative 10, y is negative 1/10, okay? Negative 10 becomes negative 10, negative 1/10. So I don't know if you're noticing yet, but if I look here, it's really the y values that are changing. My inputs stay the same, okay? My input down here was 1/2 negative. My input down here was negative 1/2 for both of those. My output was 1/2 and negative 1/2 and negative 2, okay? Same here, my input is negative 10 and negative 10. My output is negative 10, negative 1/10. The reciprocal is actually being taken to the y value, okay? Because y is equal to 1 over x. So it's the y coordinate. The x is always the input. I can control x, right? Y depends, right? I can put in my input. Y depends on my input. So this next point is negative 10, negative 1/10, which is really a small y value. Negative 10, negative 1/10. Almost at 0, isn't it? Now, oh, let's do that in blue again. So if I look at very sort of biggish numbers, the reciprocal of a biggish number, and I'm just thinking of the 10, not the negative, but the reciprocal of 10 would be a small number, 1/10. If I were to go way out here to like negative 100, the reciprocal of negative 100, my corresponding point would be negative 100 and negative 0.01, 1/100th. A very small number. How would you even write that on this graph? I don't know. Very, very close. Almost touching the x-axis. Same thing if I look over here at, some small numbers here. At this point, let's find a little point right here. Let's make it in red here. There's a tiny little point here that would be negative 1/100th and negative 1/100th. Well, if I were to take the reciprocal point, that would be negative 1/100th and negative 100. Okay, so negative 1/100th would go way down here, negative 100, way down there. Very, very far. Okay, very, very far. We're going very far. So this point down here would be negative 1/100th, negative 100. Okay, I'm going to just erase this because, of course, we don't have room for all that. And now, what my graph would kind of look like is something like this. Whoops, and we don't want to go over the x-axis, okay? Because the reciprocal of a negative number will always be a negative number. So if our y values were negative, they're going to stay negative. And this portion of our branch is going to keep on cruising down. And that's a nice, accurate depiction of the branch. Now, this, where x is 0, or rather where y is 0, okay, when we input a 0 for x and y was 1 over 0, we got undefined. And what that does is that at that point where x is 0, we went from 0, 0, which was our x-intercept right here, to 0, undefined. Okay, and we find these undefined values right where y is equal to 0. And where is y equal to 0? Y is equal to 0, right? Where y is equal to 0, which is on the x-intercepts, that's where we get a vertical asymptote. Okay, a vertical asymptote. So let's draw that in. It's going to look right like this, right along that y-axis. Okay, and that's the equation x is equal to 0. Right? And I know if I look at this and think about this from our last unit, our non-permissive value, x cannot equal to 0. What our non-permissible value is gives us our asymptote. The equation of the asymptote is the non-permissible value. So let's look at the positive values here. And when I say value, I'm looking at the values of the function. The values of the function are the y coordinates. So when I'm looking at, for example, a big number here, like 10, 10, okay, a bigger number, the reciprocal of 10, 10 would be 10. My corresponding point would be 10. X is still 10 and 1/10. So a very small number. Big numbers become small numbers. Okay, I could pick like 5. This is the point 5, 5. The reciprocal corresponding point on the reciprocal function would be 5, 1/5. Okay, there's 5, 1/5 right there. The reciprocal of 2 would be 1/2. The reciprocal of 1, well, the reciprocal of 1 is still 1, so I'm going to just put these in blue. Okay, the reciprocal of 1 is 1. And the reciprocal of 1/2 would be 2. And so on. Reciprocal of 1/10 would be 10. And what happens is we get close, we're going to move farther and farther out. We're going to move farther and farther to the right, farther and farther to the left, farther up and down. So this blue line is my reciprocal function, y equals 1/x. It is indeed a function. Okay, if I do the vertical line test, it will only ever touch once. Okay. The asymptote is not a function, and it's actually not part of the equation. It's an invisible line. Okay, it's what it will never touch. So the domain of this function is the set of all x such that x cannot equal to 0. Okay, because when x was 0, y was 0. But it's all real numbers other than that one. And the range, y cannot equal to 0. So there is our domain and range for y equals 1/x. Okay? A couple of things to notice. The x values, the x coordinates do not change. The y coordinates change. It's the y coordinates that we take the reciprocal of. Vertical asymptotes occur at the x-intercepts because at that point, y is equal to 0 on the x-intercept. Okay? And we take the reciprocal, which y is 1/that value, which is undefined. Okay? And that causes a vertical asymptote at that place. Okay? Horizontal asymptotes show the behavior of a graph when x is very large. So if I were to put a very, very huge number in this function, okay, for 1/x, okay, if I put 1 like 1,000,000, I'm going to get a very, very small number. Okay? So if x is 1/1,000,000, I'm going to get a very, very tiny number. It's going to be way over here. It's almost going to be touching my x-axis, but it won't. And the same thing on the negative side. If I put a very, very small negative number, I will almost touch the x-axis, but I won't. Okay? Some things to notice: when the original function has a y value of 0, where is that? On the x-intercepts. Okay? The reciprocal function does not exist. It creates a vertical asymptote. When the original function has a y value of 1 or -1, the reciprocal function has the same value. These are invariant points. Okay? When the original function has positive y values that are increasing, the reciprocal will have positive y values that are decreasing. Okay? They get smaller, but the signs won't change. Or if the original function has is above the x-axis, is positive and increasing, the reciprocal function will also be above the x-axis but will be decreasing. Okay? okay? And then same thing with the negatives. If they're negatives, they will stay negative, okay? They're increasing, they will be decreasing, but decreasing negative values. Okay. Let's graph another one. Instead of y equals negative x, which will almost be the same, let's graph f of x equals, I don't know, let's do like x plus 1. So I'm going to start by graphing x plus 1, which I know is a function with a y-intercept of 1 and a slope of positive 1. There we go. And I don't think I graphed that correctly. Hold on. Okay. Here we go. There we go. Of course. There's y equals x plus 1. Now, if I want to graph the corresponding reciprocal function, let's first write that. Okay, let's first write that. This would be f of x equals 1 over x plus 1. So let's right away look and see, okay, what can we get from there? What values do we know from there? Right away, I know that if I look at my non-permissible values, okay, I know, looking at my denominator, that x cannot equal to negative 1. And where x is equal to negative 1, okay, x equals negative 1 is a vertical asymptote. Okay, because where x is equal to negative 1, well, of course, that's my x-intercept, and y is equal to 0. So I can draw then my vertical asymptote at x equals negative 1. Okay, so the first thing I do is find my x-intercepts. Okay, I'm going to, number 1, graph the original function. Okay, number 2, find the x-intercepts. Number 3, draw the vertical asymptote. Number 4, I'm going to find where y is equal to plus or minus 1. So I know that y is equal to 1 anywhere along this line. This is the equation right here, this green line, that's the y equals 1, and this is y equals to negative 1. So I can see right away that this point here and this point here, the reciprocal of 1 will be 1, and the reciprocal of negative 1 will be negative 1. So therefore, I can right away draw those lines, and I can find my invariant points, okay? These are invariant points. Once I know then that I've got these few values, I'm going to just erase the line, okay? I've got those 2 points, and I know that my asymptote is here in the red line. I know also that I'm going to look at these positive tiny numbers right here between 0 and 1. Whoops. And I can replace those positive tiny numbers with positive big numbers, right? These are small y. If I look at the y values here, they're between 0 and 1. Okay, those are tiny numbers between 0 and 1. So if I take the reciprocal of those small numbers between 0 and 1, I'm going to get a big number, right? The reciprocal of a half would be 2. The reciprocal of 1/100th would be 100. The reciprocal of 1/10 down here would be 10. And then if I take these bigger numbers here, the reciprocal of 10 would of course be 1/10. The reciprocal of 9 would be 1/9, right? I can see them so clearly. The reciprocal of 5 would be 0.2, okay? The reciprocal of 2, this would be where y is equal to 2, would be 1/2. So I have an idea, I kind of get the idea that our graph looks like this. Okay, we have an idea of what this looks like. And that is indeed it. Now that's a pretty good branch that I drew there, if I do say so myself. And what I mean by that is when I draw my branch, I don't want something like this. I'm going to draw a bad one in purple. I don't have my graph bouncing like this. Okay, that's definitely not a good. My graph should look like it is approaching the asymptote, both the vertical and the horizontal, and it's getting closer to the asymptote. It'll look almost linear, but I don't want it, once my graph starts approaching, it shouldn't come back out, right? It should never do that. It shouldn't be just a straight line like that. That's not a good graph, okay? So we can kind of practice that a little bit more later, but let's look at the values over here. Let's do the negative branch. Okay, again, the reciprocal of these tiny y values between -1 and 0 are going to be bigger negative y values. So the reciprocal there of like -1/2 would be -2. The reciprocal of -1/10 would be -10, and so on. So our graph is kind of going to screech like that. And then these were bigger y values, right? From here to here, our values are greater than or equal to 1. Okay? We can say y is greater than or equal to 1. Okay, so the reciprocal of 1/5 would be, so the reciprocal of -5 rather would be -1/5. Okay, the reciprocal of -2 would be -1/2. And so our graph is going to sneak along like this. And it's approaching the x-axis closer and closer. Okay, so the green value here, the green line, that is my reciprocal function of y equals 1/x+1. I found those invariant points, and then I plotted a few other points, okay? Envision a few others, okay? We could plot a few others. And connect the dots. Connect the dots. Okay, and let's look at the domain and range for this function. The domain would be the set of all x such that x cannot equal to -1, but it's all other real numbers. Okay, that's my non-permissible value. X can't equal -1. The range, the set of all y's such that y cannot equal to 0. Okay, and I know that y can't equal to 0 because if I put a huge number in here, a huge positive number, if I say let x equal like 1,000 or even like 1,000,000, okay, let's make it a really big one, like 1,000,000, 1, 2, 3, 4, 5, 6, we need 6 zeros. If I put x as 1,000,000 in there, my function f of 1,000,000 will be 1/1,000,000 and 1. And if I divide 1 by 1,000,001, I'm going to get a very teeny tiny number. Teeny tiny. Okay, so if I approach out here, it's going to be very close to 0. If I have one candy and I split it between 1,000,001 people, we're pretty much going to get nothing. But not quite nothing. If I could just, get out my micro cutter and snip that one candy into 1,000,001 pieces, we would all get something. Next to nothing, but it's just going to be next to nothing. It's not going to be nothing. And same thing if we put in a negative value. If I put in a -1,000,000, we get f of -1,000,000 would be 1/negative, that would be 999,000, right? 999,999. Again, if I take $1 and split that between 999,999 people, okay, we're each not going to get too much, okay? And if I say they're going to share in my debt load, it's a very tiny, tiny debt. People wouldn't be too horrified by that. So what happens is I'm going to approach a very teeny, tiny negative, teeny, tiny number, okay? So I approach 0, and that's why I know that my horizontal asymptote is going to become 0, right? This value here I'm going to get closer and closer and closer to 0, but I'm never going to reach 0, both in the positive and the negative direction. Okay? This is very Math 31-ish, okay? And you see a little bit of this in Math 30 as well, okay? Let's do one more here together, and then I'm going to let you try the last one. So first thing, let's find the reciprocal function. F of x is 2x plus 5. Let's graph that. 2x plus 5, there's 5, up 2 over 1, up 2 over 1, down 2, left 1, etc. Okay. There's our graph of y equals 2x plus 5. Starting at my y-intercept with 5 and up 2 over 1. Now, the first thing I want to do, what did I say my steps were? I just do it. Okay, graph the original function, find the x-intercepts. Okay, right away, well, let's find the reciprocal function first. So f of x is 1 over 2x plus 5. There's our reciprocal function. And right away, I know if I look at my denominator here, I know my NPV, x cannot equal to negative 5 over 2, or negative 2.5. And lo and behold, that's where my x-intercept is, at negative 2.5. And what does that create there? That creates, right, that creates, that's not a very good graph. Let's just see if I can straighten that out there. That's better. Okay, that's my asymptote. And, whoops. I'm trying to choose this. Here we go. I thought that would do that. Maybe it's not going to. Oh no. Okay, let's do that again. Here we go. Okay, there's my negative 2.5. Whoops, and that's x is equal to negative 2.5. That's my equation of my vertical asymptote, okay? And that happens to be my x-intercept on my graph. So once I know my original function, I find my x-intercept, that's where I draw my vertical asymptote. Bam, that's my equation, okay? The vertical asymptote of the equation x equals negative 2.5. And that comes from my non-permissible values. That's what my value is not allowed to be, okay? My horizontal asymptote, if I put a really huge number in here, I'm going to be dividing by 1 over a huge number. Because if I took a huge number and times it by 2 and added 5, it's still going to be a huge number. And 1 divided by a huge number is going to be a very small number. Okay, so I know that my horizontal asymptote is going to be my x-axis. Okay, because it's very, very close to 0 on both sides. If I put a 1 over a huge negative number, then I'm going to get a very small negative number. Okay, very small negative number. So we'll look at that a little bit more detail in a minute, okay? Now, let's graph this function. After I find that value, I found my vertical asymptote. I also want to envision here, where is y equal to 1 and y equal to negative 1, okay? It's along here, isn't it? Oops. Y equals to negative 1. Let's draw those lines to start, okay? Not quite there, but right on the y equals 1 and negative 1, okay? So that means this here is going to be an invariant point, and so is this. So that's right where y is equal to 1 and y is equal to negative 1. And if anyone's picky, they'll see that this should be right on there, okay? There we go. So these two blue dots are my invariant points. So this isn't bad. I draw the line, I find my vertical asymptote, I find my two values where y is equal to 1 and negative 1. Now I just have to envision or think about, okay, where do these points come from? Where do they look like? Let's do this part in, I don't know, orange, okay? Little numbers here become big numbers. So the little numbers come from up here. Go through that invariant point, And these little numbers here, little became big. These big numbers, these big y values become little numbers, right? Down there. So this is going to look like this. Whoops, and it should not be bouncing back up. Let's just, okay. And it's going to get gradually closer and closer and closer. And it almost looks like it's touching, but it's not touching, it's just above. Okay? And same with this one. And this is going to go on to infinity in both directions. And then let's look at the other branch. Okay? Negative numbers stay negative, so we're not going to cross this x-axis. Okay, and there is our negative branch. And there's our function. There's our reciprocal function. Y equals 1 over 2x plus 5. Okay, let's look at the domain and the range of the reciprocal function. So our domain would be the set of all x such that x cannot equal to negative, what was it, 2.5, negative 5 halves. And the set of all y's such that y cannot equal to 0. Okay, I would like you now to pause the video, and why don't you try graphing these two functions, okay? Go on and try it. Don't just wait for me. Go ahead now, pause the video. Okay, so hopefully you got the same equation or same graph that I did. I would definitely recommend you do some homework, 1AB, 2AB, 3AB, 4AB, 5AB, 6AB. Check your answers. We'll save question B for review in class. But yeah, and the process is the same. You graph the original function, okay? Find the x-intercepts, that gives you your vertical asymptote. Label the equation of the asymptote. So in this case, the asymptote equation is x equals 3. If you were asked to find the actual equation of the reciprocal function, it would be y is equal to 1 over 3x minus 9. And of course, 3x minus 9 cannot equal to 0. So 3x cannot equal to 9, x cannot equal to 3. So that's why x equals 3 is the equation of the asymptote. Okay, this is our non-provisible value right here. Okay. Yeah, find your invariant points where y is equal to 1 and negative 1. And on this graph, that's of course right here. Okay, and right here, those are invariant points. And then you can fill in the points, okay? Fill in the rest of the branches. Okay, and just for bonus math, I give you the domain and range. X cannot equal to 3 and y cannot equal to 0. Okay, there are no x-intercepts on this graph, but there is a y-intercept here. Our y-intercept on our original function was 0, negative 9, okay? 0, negative 9 is our original y-intercept, and the intercept of our reciprocal function here would be 0, negative 1/9, okay? Because of course it's the reciprocal of the y coordinate that changes. Anyway, I hope that helps. Good luck on your homework, and we'll